Thank you for coming. Welcome to FSG Global. This is Leo Torres. This is LLMs, computation or measurement. And this is a thermometer. As you all know, thermometers are made with a vacuum tube that contains mercury. When the mercury gets hot, it expands and it rises up accordingly to a certain height. The thermometer has these markings on it so that you can then visually compare against the height of the mercury, and that gives you a reading of the current temperature. Those markings are in a particular scale, usually Celsius in most of the world, or Fahrenheit if you're in the US. These two scales give different readings. 32 Fahrenheit is the same as 0 Celsius, and so on. So the readings made in different scales may be different, even though the underlying physical principle is, of course, exactly the same. You can even make your own scale. You can take the logarithm, for example, of the reading in Celsius, and now you have your own log Celsius scale. And the reading will be different again, but the physical phenomenon by which mercury rises inside of the tube is still the same. I swear this talk is about LLMs. I'm gonna get there in a second, just bear with me. Because what I'm trying to draw your attention to here is that there are two different things happening here at the same time. There is an underlying physical phenomenon that involves temperature and volume and pressure, and then there is a quantification of that phenomenon that gives you a numerical reading. You have to understand the first one in order to do the second one. And once you understand the first, you can choose how you want to do the second one, whether it's Celsius or Fahrenheit or log Celsius. So that second activity here, taking and conveying that reading, is a data presentation issue. It's a convention, whereas the first, understanding how temperature affects the volume of mercury, is a scientific issue. This is a computer. A computer is not a measurement instrument. A computer is a machine that works by executing algorithms over data. It does so by pushing electrical currents through circuits made of billions of transistors in such a way that if you put in the right configuration of currents in one end, then out the other end you get a configuration of currents that can be interpreted in meaningful ways. So if you put in plus 2 and 3 in one end, you get 5 out the other end. And that translation from a configuration of electrical currents to the number 5 is also a convention, much like choosing between Celsius or Fahrenheit is a convention. In computers, for example, you need to choose the endianness of your bytes, which is whether the first bit in a byte is the most significant digit or the least significant digit. So there's still a convention about data interpretation that we have to agree upon here. And there's still an underlying principle. In this case, I would say it's both physical and mathematical principle that governs how computation is carried out using electrical currents. So, two different things happening at the same time. My entire aim for today's talk is to put these two things side by side and to put all of these concepts in your head while we have a conversation about what are LLMs really doing. Is it computation or is it measurement? Now, I don't mean to be intentionally equivocal here. I do think that LLMs fall squarely on the computation side of things, but I also know that some of us are already using LLMs as if they were measurement instruments. For example, here at FGS, we are the first ones to cast that stone. We are using LLMs to measure all manner of qualities of unstructured text data. For example, sentiment, named entity recognition, topic modeling, and a slew of other things. We used to do all of these tasks with classical NLP algorithms, which without a doubt fall firmly on the computation side of things. But now we're using LLMs for all of this because the assumption that we're making, and dare I say, the assumption that everybody using LLMs these days is making, is that LLMs understand text in a way that classical algorithms did not. And all we're doing is use these LLMs to get a reading that comes from that understanding, much like we use thermometers to get a reading that's based upon the understanding of some underlying physical phenomenon. So my aim for today is not to convince you of this point that LLMs are laboratory-grade measurement instruments, but rather to perform a sort of thought experiment and ask ourselves, what if LLMs were measurement instruments? And just to explore what that entails, because even if they are not today, maybe they will be in 5 to 10 years. These things are evolving at an incredibly fast pace. I don't need to tell you that. So let's assume that they are. Let's assume that we can actually conceive of LLMs as measurement instruments and see where that leads us. The first thing one should think about when performing measurements in a laboratory setting is measurement error. So this is what we call it when we perform the exact same experiment under the exact same conditions with the exact same instruments, and yet you get a different reading. So there are a million reasons why this could happen, including random chance, and a lot of these reasons are well understood, well studied, but what's important about this is that scientists had a plan to deal with these kinds of errors. We know what to do about them. Let me give you an example. So yesterday I asked our friend ChatGPT on a scale from 1 to 10, where 1 is extremely negative and 10 is extremely positive, what is the sentiment of the following piece of text? And then I copied a paragraph from a recent sports news articles. GPT responded by saying, on a scale from 1 to 10, the sentiment of the text would be around a 4. Fine, it's fair. Then I asked it the exact same thing, same prompt, literally copy-pasted, not 10 seconds after it answered the same thing, and I got a different answer. On a scale from 1 to 10, the sentiment of the text would be a 3. First of all, don't worry, I am not using this prompt in production. This is a terrible prompt. This is a terrible prompt. If you really want to use LLMs as measurement instruments, you absolutely need to have more involved prompts and spend some time doing some prompt engineering. This is not a production story. It's just an experiment that shows that LLMs in general are actually capable of making consistency mistakes that, when used to make measurements, resemble the kind of errors that scientists deal with all the time. And not only this, but there are other sources of error that we all know and love, like hallucinations and temperature, which in this setting can be considered also a source of error. So I said that scientists have ways of dealing with measurement errors. Do you know what we do? We literally run the same experiment 3 times and then average the result, and that's it. That's it, that's science. So, well, first of all, you can show that if the error you incur in has a 0 mean, then averaging out actually gets rid of some of the error, but that's not the point here. More importantly, we actually include the errors in our readings by reporting confidence intervals rather than point estimates. I would love to tell you today that I have a complete theory for how to devise confidence intervals when using LLMs, but I don't. If you know how to do that, if you have thoughts about that, please let me know. Instead, what we can try to do is just apply this principle where we can. For example, by using different versions of the same prompt on the same input and then averaging out the results. Again, this is somewhat a silly example, just for the sake of argument, but if you're able to take your prompt and write several different versions that should return the same value, then I recommend that you use all of them rather than try to find a single prompt that's the best among all of them and average out the results. One other really important component of measurement instruments is that measurements are never taken in isolation. So every reading you get is made according to a certain scale, like Celsius or Fahrenheit. So whenever you take a measurement, you're actually comparing your reading to a standard reading. For example, 1 Celsius is 1/100th of the temperature between the freezing point and the boiling point of water at 1 atmosphere of pressure. So when you take a thermometer, when you use a thermometer and its markings are in Celsius, you're actually comparing your temperature to the temperature it takes to boil water. So if we're using LLMs to measure, for example, sentiment with this prompt, then it's actually really important to have some standard to compare against. And in the absence of a physical, scientifically understood and agreed upon standard for text sentiment, I think the best we can do currently is make extensive use of few-shot learning. So instead of this prompt, where the readings are taken completely in isolation without comparing them to anything, we should be using something like this, where we explicitly illustrate exactly what kind of text should receive a 1 or a 5 or a 10, and so on and so forth. My point here is not to just say use few-shot learning. I would hope that all of you are already using it and aware of it and using it as much as you can. My point instead is to say that you should probably spend just as much time, if not more, developing your standard scale as you spend engineering your prompts. This should be a first-class citizen with high priority among the tasks on your to-do list. Your entire organization should be aligned to agree that it is a good investment for your developers to identify, curate, maintain, and revise the scale against which you are taking your measurements. Because otherwise, if the LLM gives you a rating of 3, there is absolutely no systematic way of interpreting what that is supposed to even mean in any way. If you ask me what's the temperature and I say 32, you should always ask, is that Celsius or Fahrenheit? Because a reading without a standard is meaningless. This actually leads me to my last point about this. In an ideal world, we would have a single standard for measuring sentiment or other qualities of text, but unfortunately we are very, very, very far away from that. So that's why you have to develop your own standard that serves your own purposes, that is aligned with your business needs, and that everyone in your organization and customer base understands. And because it's so messy, and because there are so many stakeholders, and because your application and your understanding of the problem space will evolve, your standard needs to evolve as well. As a real-world example, did you know that the definition of the meter changed in 2019? So before 2019, there was a metal rod kept under very strict conditions somewhere in Paris. This was the meter against which all other length measurement instruments were calibrated. But in 2019, the definition of the meter became the length of the path traveled by light in a vacuum during a time interval of 1/299799245 of a second. And that's a better standard. Now just think about that, right? Like every measurement tape, every ruler, every signpost along the Autobahn, every single time that you've measured length in your life, the meaning of that reading actually changed in 2019 when we made this change. Granted, it changed so little so as to not have any implications in practical real life, but it did change. It changed because our understanding of the physical universe changed, and so our standard needed to reflect that. This, by the way, is a picture of the meter, or at least what used to be the meter before 2019. We don't need it anymore. So, develop your own standard of measurement and get ready for the standard to change. This is far from a trivial task since your entire organization and your user base will be affected, so you have to have a plan for it. You need to invest time and effort in aligning all of your stakeholders and prepare them for the potential eventuality that this standard will change. Because not having a standard or having a standard that does not evolve with your application is probably even worse than that. So the next time you use an LLM to make a measurement of some piece of text, I've been using sentiment as kind of a running example, but pretty much any prompt that relies on the assumption that LLMs understand text can be conceived of as making a reading of some sort. I suggest that you think about some of these things. Think about measurement error. Have a plan to deal with it. Try to report intervals rather than point estimates and average out the error if you can figure out how to. Identify, curate, maintain, and ultimately care about the standard that you're comparing against, because otherwise your readings are meaningless. And you have to stick to it for as long as you can and then leave it behind when your understanding of the problem evolves. Your standard should evolve with it. Your standard should be a feature of your application, and all features can be improved. We really have only scratched the surface of what can be said and done about LLMs as measurement instruments. There's a far larger discussion to be had here, ranging from the philosophy of when computation becomes measurement to the engineering practices that we have to adopt in order to have a measurement standard be a first-class feature of your application, to the business models we can devise for a product that involves something akin to measurement in a laboratory setting. There's a lot to be said about this. And again, even if LLMs are not quite there yet, I think there's little doubt that they will be at some point, maybe sooner rather than later. So let me spend a few minutes telling you why at FGS we're even thinking about these things, what product are we building with large language models that led us down this path. We are building Media IQ. These are automated, LLM-powered media analysis service. Like Till said, we are a strategic communications consultancy, so we help your organization generally navigate the landscape and understand and reach its different stakeholder groups, from customers to other businesses to governments to journalists and so on and so forth. So a key element of what we do is just read the news, right? So a non-trivial amount of our colleagues' time is spent reading the news and understanding how your organization is portrayed in the media. So we're automating that process by having chatbots read the news for us, because we are assuming that they understand text well enough to do that, or at least well enough to complement our own understanding of the news. So we have access to the full text of tens of millions of news media articles from all around the world, both from print and online sources that we process using a big messy pile of LLM prompts, each of which is measuring some qualities such as sentiment, extracting named entities, identifying trending topics, assessing relevance and prominence, etc., etc., etc. Each of these tasks can be conceived of as performing some kind of measurement, and each of these tasks requires a standard that measurements can be compared against, and that keeps evolving with our understanding of our dataset. Once we have all of that, we run some of the run-of-the-mill statistical analysis, we crunch the numbers, we do the math, we do our homework, and we deliver that to our consultants so that they can convey data-based, evidence-backed, LLM-powered advice to your organization. And in the future, we're also working on putting all of this into a dashboard product that we can ship to our clients directly so they have 24/7 access to our analysis. So just imagine these kind of plots, but in an interactive dashboard that updates every hour or so with the latest news. Due to how technical this gets and the scale of the corpus that we have access to, things can get quite messy in the back end. For example, this is a data flow diagram of one of our main ELT pipelines. So the big red scary circle in the middle is actually pulling a lot of weight here, because if you double click on that thing, it actually looks like this. And if you squint a little bit, you will see there's 3 of these steps that have a red star on them. And that means that each one of those actually looks like this internally, right? Because as I said, things can get quite messy for an application of this scale. Now, I am not trying to impress you with the complexity here. I could have just thrown that together in a completely meaningless way. It's not meaningless, it actually comes from our archives. But what I'm trying to do here is that we are used to dealing with the complexities originating from cloud infrastructure, distributed computing, streaming data, and so on and so forth. We are not used to dealing with the complexities of measurement. Otherwise, I would be showing you all of the diagrams related to measurement. Replicable, error-prone, standardized, evolving measurement. And I wish that we were more used to that. I really do. I think that as an industry, this is something that we need to continue to grapple with head-on instead of taking it for granted. All of these diagrams, the infrastructure, the operations, the architecture are no longer the full story. We need a quality assurance practice applied to LLMs that is distinct from the QA that we perform on code or data or infrastructure, that's based on the entirely different principles of scientific measurement. So if you relate to any of this, and I have piqued your interest in one way or another, let me know. We're hiring. And let me know your comments. Do check us out. We are the Data and Insights team here at FSG Global, based in Berlin. We have an awesome team of 10 full-time employees. We work with a dozen or so external contractors or freelancers. most of whom are also working with us full-time, not free-time. So it really does feel like we're putting together a small startup in a larger organization. So we're building MediaQ and 2 other products, and we also have big plans for the future. So thanks a lot for your attention. Happy to hear you guys.
Can you hear me?
Yeah.
Okay, any question from the audience? Is one there?
Okay, really philosophical talk, I like it. Let me maybe pose a philosophical question which probably you already kind of inferred towards, right? So for example, you talked about changing your standards, right? And the example that you gave with the meters and everything, the standard changed, but the impact was so little that it did not really matter.
Yeah.
But specifically in the case of LLMs, when you change the standards, like in the example you gave, like 1, 5, 10, 3 sentences, right? Mm-hmm. Let's say I change those sentences and everything I had done so far changes, like whatever evaluations I had done so far changes, right? So the impact is not so insignificant compared to the example of the meter, right? So how do we tackle that scenario if everything just changes there when I change my standard?
You should come work with us. That's exactly the kind of questions that we are asking, right? And even though I don't have a general answer for that, part of what we're trying to do is you don't know what's going to happen, or basically who's going to complain, hint your customers, when that change happens, but it will happen. So the least that you can do is, as you're planning that change, what you can do is say, instead of going to your customers or your clients or users and say, by the way, everything changed, forget about all of those, that's meaningless anyway. You cannot do that, right? You're going to lose your clients. What you have to do, or you have to try to do, is say, look, we're changing it, we're calling it MediaQ 2.0, it's better, it's improved, and here is how you transition, right? You have to figure out a way of, if it's possible at all. Sometimes it's not possible. In that case, it's a problem of communicating that to your clients, and maybe you should ask for the help of a communications consultancy in that case. But if you can have a transition plan for that, then absolutely you should try to have one. It's exactly the same if you think about software development, software engineering. Sometimes you have breaking changes, and you have to communicate that, and you have to have your users migrate with you. That will happen, and everybody just has to know it and deal with it. So smoothing out that transition is what's most important, rather than pretending that it's not going to happen. Does that make sense?
Yeah, sure, thanks.
Thanks for the talk. What was the reason to use LLM for this particular use case in the first place? And did you measure if there was an improvement?
Interesting question. So, I mean, the number one reason is that, like I mentioned, we believe that LLMs understand text with far more nuance than traditional NLP algorithms. We knew that we needed. Excuse me, that's a beer. We knew that we needed to automate a lot of what we already do in our bread and butter of our colleagues, right? So we identified this as a need for our business. And we could have done classical NLP algorithms, or we could have done LLMs. And the thing is that LLMs understand text better. There's nothing more than that. We started this product using LLMs, so there's no before and after, there was no transition, so we cannot make a direct comparison to that. And in fact, like I've been saying, quality assurance of like how well is the LLM performing this task is an uphill battle that we're dealing with every day right now. So right now, some of the things that we're doing is we're manually tagging, or we're manually analyzing some of the text in a similar manner as what we're asking the LLM to do, and just comparing that. That gives you some data points. It doesn't give you any sort of statistical guarantee for anything, but it gives you something. And like I said, we are very much, in some ways, not everything that we're doing is like this, but some of it is, we're automating some of the stuff that our colleagues are already doing. And so the only way of directly comparing this is by having the LLM do it and having a human do it and just comparing it. In terms of evaluation metrics or having a more quantitative way of comparing that, I would love to have that. But once again, there's no quantitative standard for measuring sentiment or for doing this or for that. Oh, not that I know of. If you all know one, just please tell me. So that's a lot of words to say. We're working on it, I guess.
Thank you.
Okay. You said you cannot compare with something, yeah, but you can compare with baseline. You can compare it without few shots learning and with. And it would be interesting to see these numbers. Do you have manually labeled data? Do you have some?
I don't have numbers right now for you, but the thing is that you still need a human to manually tag these things. In order to have some kind of ground truth so that you can apply any kind of evaluation metric, you need to have a human do it. And the thing is that I don't know how useful that would be if I have a human or an army of humans tag 100 or 1,000 news media articles along all of the dimensions and all of the things that we are asking the LLM to do, and then have 1,000. Let's say we do 1,000 articles. Well, the LLM is doing 5,000 articles every hour. So the scale here, like again, there's no statistical guarantee because the sample size would be far too small, and I'm not sure that how much use that effort would be.
I just interesting if it's few shot learning better than just average.
Yes, it is.
I believe it.
Yeah. We're in the process of making all of those determinations, but it is.
Okay, thanks. So first, thanks a lot for the presentations. It was really nice. I was having a question, but then I realized I have a better question. So, okay, you are saying about the importance of getting a number that is consistent across a project. Okay, and if I understand correctly, you do a bit like sentiment analysis, correct? Okay, good. I was wondering if you looked at increasing the number of adjectives the number of sentiments that you want to extract from the text, like increasing the resolution of the size of your vocabulary. If you increase it a lot, I would guess that numbers, getting a specific number is not very important anymore. Is that correct?
Yeah, I think you're on the right track here, because one thing that you can do is, for example, just feed in a manually curated piece of text that uses some kind of word, and then you do the exact same thing under the same conditions, yada yada yada. But you change one adjective and you exchange it for its superlative, right? I think one of these things, that's what I was trying the other day. So the piece of text here says something like, in the coming days, the Celtics, NBA team in the US, will smartly talk about all the ways that Indiana can create problems for them, but the truth is the Pacers, another NBA team, reached this point by siding past the Bucks and the Knicks, other NBA teams whose rosters were absolutely decimated by injuries. I think that word decimated was like intentionally chosen by the journalists who read that, and that is what we're trying to detect, to sense, to get a reading of when we do all of these measurements. So what I was trying to do is change that adjective. Instead of decimated, you do something like annihilated or something like that. And so what you can do in order to incorporate this in as part of your QA pipeline is to get this and exchange that adjective and expect the LLM to give you a more intense reading. So if the reading for this was average of 3 plus or minus 1, because we're using confidence intervals, right? And you change that one word, then you would expect it to be 4 plus or minus 1 or something like that.
Okay, yeah, thanks. Sorry, I didn't phrase it correctly. I was not talking about the inside adjectives inside the prompt, but you are measuring something, right? You are measuring if people are very angry or if they are nostalgic or something.
Sure.
I'm asking if you have tried extracting multiple measurements on the same text on different adjectives, like nostalgic, sad.
Right. So instead of measuring sentiment in one number, you want 5 numbers in different dimensions.
Yes.
Yeah. Maybe that may or may not be something that we're doing as we speak. But so the thing is, one thing that we're doing is we're measuring the general sentiment of a piece of text. Just tell me from 1 to 10 or whatever, and also more targeted sentiment. So tell me what is the sentiment of this piece of text related to the Pacers or the Knicks or whatever, right? So we are trying to measure the same thing from different angles. Exactly. So, and that is nice, and it gives you a broader picture of what you're trying to measure. It also makes things messier, because now you're measuring slightly different things on a scale that kind of looks the same, but they're not exactly comparable to one another, because you're measuring different things, right? Yeah. It's apples and oranges. So it's good to do that, and it's also bad, because you need all the more QA on it. Thank you.
We have another question here.
Okay, so I tried to explain it. I think you already talked about it, but you already probably came across. So I think it's like pretty simple with human and human relationship is you can brainwash your language model in a sense. You ask sort of another LLM language model to create a lot of text in a certain, let's call it, experiment framework. Let's say like, okay, I want this, and you behave in a certain way. So basically you automate, you replace sort of human from the loop, and you automate everything with sort of adopting language model also to create a lot of, let's say, context in order to use it in ICL, so in context learning. And you kind of brainwash like human. Just imagine you grow up in a Christian or I don't know, religious family, you're brainwashed constantly by a specific mindset. At the end, you know, the way you talk is not measurable at all, because it's your brain, you create different sentence. And maybe I talk right now about this topic. If you ask me again, I might come up with a different narrative. It's not fixed and it's not easy to sort of measure it. But you can brainwash me to talk in a certain way that is always along the same direction. So I would say if you automate the ICL in a certain manner with like other language model to create a lot of context, and a certain, like I came across a paper a couple of days ago, they call it ICL Plus, that you come up with a certain sort of order of giving information to a language model, and the output of sort of, let's call it, the result in the sense of learning will be way better. I think that might be something.
So I see what you're saying. So you can use an LLM to generate more data in a particular sort of more controlled environment. I think I would have to consider what we would use that for. And I say this for two reasons. One is that we don't actually need more data. We have more data than we need, right? Generating more data is something that you know, we don't need more data. We have enough. And the other thing is that something that I didn't have a lot of time to talk about today, but I also, it's also something that I've been thinking about, is the fact that there's bias. There's a huge amount of bias in how we train LLMs. You all know, what I'm talking about. Like there are less than savory things that happen with the fact that 20% of the input data for like OpenAI's LLMs comes from Reddit. And Reddit is not a nice place. So I would be a little slightly concerned about if I ask an LLM to generate more data, that's just going to reinforce the biases that already it sees there. Because that's not what we're trying to do. We're not trying to understand text in a vacuum just for the sake of understanding text, though that's really interesting. We're trying to understand how the news portrays your organization, right? And so if I ask an LLM to generate more context data around that subject, I think that would presume the assumption that I assume not only that the LLM understands text, but that LLMs understand how media portrays your organization. And I think that's a much stricter assumption that I don't know if I'm ready to make that yet. Does that make sense?
Okay, I think we can stop here. So thank you, Leo.